It's all very well looking at one event at a time and trying to work out what's going on, but as physicists we want to answer questions about the universe, not about individual particle collisions. To claim that we have, for example, found that the Higgs boson really exists, we need to combine the results from many collisions. I've processed 35 events so far, which is nowhere near enough to make any real discoveries, but let's have a look at the results so far. One of a particle physicist's favourite tools is the mass plot, a histogram of the invariant mass of groups of particles from many events. We can look at some of these histograms in Hypatia. In the invariant mass window, there's a menu called histograms with various options. Let's have a look at this one called M2 histogram. This shows a histogram of the invariant mass of pairs of particles that we've identified. Let's expand this a bit. So we can see that there's a big peak here, which is at a bit below 100 GeV. And this is in the region where we would expect to find the Z boson. If a Z boson with a mass of about 90 GeV decays to 2 electrons or 2 muons, then the invariant mass of those particles should be around 90 GeV. And we see that there are quite a lot in this region. However, there are also quite a lot with lower masses, which could come from other types of neutral particles we know about. And there are a handful at very large masses, which is less expected, but the data that we're looking at today might have some surprises hidden in it from simulated data. So we should be having a look and trying to spot unexpected behavior like this. This histogram includes all pairs of particles, but we can look at the different types of particle individually. This one, MEE, will show electron-positron pairs, and here there's certainly a strong peak at around about 90 GeV. We can look at this MM histogram. This is from the muon mu plus mu minus pairs, and here we haven't got any events at very large mass, so the computer has automatically zoomed in on this low mass region, and we can see that the peak really is at around about 90 GeV, where we would expect to see the Z boson. We can have a look at MGG. This stands for gamma gamma, so this is the invariant mass of pairs of photons. We don't have as many of those, and those that we do have are a bit more spread out, so we can't really see any strong peak here. In fact, this is one of the other channels where the Higgs boson was discovered, so if we collected enough events we would see a peak at around about 125 GeV, but it would take us an enormously long time to process that many events by hand. The last histogram I'm going to look at for now is calculated from those events where we have 4 leptons, so 2 pairs either of electron-positron or mu plus mu minus. Now this is another channel where we might, if we had enough events, see a peak at the Higgs mass of 125 GeV, but clearly we have nowhere near enough events at the moment.